So proportionally, we're going to look at when you have a parallel line in a triangle, it divides the sides up proportionally. I wrote a proportion down here based on the side splitter theorem, which because this line was parallel to this line, it allows me to say that that side over that side is now proportional to this side over that side. And that reflects what I wrote down here. So let's look at the application of this. We've got a parallel line, parallel to a side in a triangle. So that means that that side over that side is going to equal that side over that side. So the proportion that I'm going to set up will be 12, this side right here, over x plus 1, this side right here, is equal to, now I use this top side in my first proportion, I'm going to use the top side in my second proportion, 9 over the bottom length x. So then I can cross multiply, so that'll give me 9 times x plus 1 equals 12 times x. I distribute, 9x plus 9 is equal to 12x. I will subtract 9x from both sides. That gives me 9 is equal to 3x. I will divide by 3, and that gives me 3 is equal to x. So there's my solution. So I'm saying that 12 over 3 plus 1, which is 4, is the same thing as 9 over 3. If I were to write that out, 12 over 4, 9 over 3, does that equal each other? You can cross multiply and check. What's 12 times 3?
36.
What's 4 times 9?
36.
So since it worked for cross multiplication, that's a true statement. So yeah, it's true. Now, what would be cool is I could take a diagram like this. I could give you this value of 10 right here, and then I could ask you the question, find the perimeter of the triangle. And then you'd have to do exactly what I did over here, plug the values in and get 12 and 4 and 3 and 9, and then you'd have to add them all together to get the perimeter. That's what I would call a Common Core test question, because I'm taking just this simple process right here of solving for x, and I'm putting it in the form of a question that you need to solve for x to answer.
So once I find x and I put it in the equation, then how would I solve it to get
10? You didn't listen to what I said. I said if I gave you this value as 10, now I could ask the question, solve the perimeter of the triangle. All right, so y'all do this one right here. Find the value of A. That's all I'm going to ask you to do is just find the value of A. So what's the value of A? I'm going to start out by recognizing that these lines are parallel. So these line segments form a proportion. I'm going to write my proportion as A over A plus 4 is equal to 12 over 18. I'm going to cross multiply. And so when I cross multiply, that's going to give me 18A is equal to 12 times A plus 4. I'll distribute. And when I distribute, that gives me 12A plus 48. I'll subtract 12A from both sides and get 6A. Then I'll divide both sides by 6, and A comes out to be 8. Everybody okay with that? You and your partner come to that conclusion?
Yes, we can take that.
All right. There is a... Here, let me go ahead and erase all this stuff. It should have been erased before I started. All right. There is another corollary to the side splitter theorem that takes it outside the concept of triangles and says if you have a bunch of parallel lines and you cut them by 2 transversals or however many transversals you want, it divides everything out proportionally. So what I'm saying is, since this line is parallel to this line is parallel to this line, then this segment over this segment is proportional to this segment over this segment. Or you could say this segment over this segment is proportional to this segment over this segment. However you want to set it up. So here, we have a problem in where we have 3 campsites are shown in this diagram, and we want to know the length of side A along the river. So I'm going to call that X. So to find X, I should recognize that all of these lines have been divided up proportionally to all of these. So I want to find a pair of river versus side that I have both numbers for. And that's this right here. So 8 over 7.2 is going to be one part of my proportion. And then now I want to use the other information that goes with the variable I'm trying to solve for, x over 9. So I did riverside over campside side and riverside over land side. I'll cross multiply, I'll get 7.2x is equal to 72. When you divide both sides by 7.2, x comes out to be 10. Now, you could set it up differently. You could say this over this is equal to this over, or you could, I'm sorry, you could say x over 8 equals 9 over 7.2. You could compare this side with this side and this side with this side, and that comparison, those ratios would still be proportional. When you cross multiply, you'll get the same thing. I just like doing it like this for some reason. I like looking at the segment of one line compared with the segment of the other line, but notice the book uses the segments of both one line and compares it with the ratio of the segments of the other line. It doesn't matter. Because of the properties of proportions, I can rewrite this as AB and BC in the top and WX and XY in the bottom, and those are equivalent proportions. So in section 7.1, you should know from section 7.1, these two are the same thing. So when I explain it, I'm always going to say this segment compared to this segment, I'm going to form the ratio with those, and then I'm going to form the other ratio with those, and I'm going to set those two ratios, the ratio of the circles equal to the ratio of the squares or the rectangles for my proportion. Yes, ma'am.
So on like the triangle things we did earlier, could you do like this side and this side compared to?
Yeah, so I could have said a over 12 equal a plus 4 over 18.
Okay. And it just comes out to be the same.
And notice when you cross multiply, you still get 18a is equal to 12 times a plus 4. So this is the step at which you need to check to make sure we've got the same thing. If we've got the same thing at this step, chances are you set it up right. And basically, it's just kind of personal preference as to how you want to set it up. So go ahead and work this one right here. This is finding length site C. I'll call it Y. Solve for Y in this proportion right here. All right, let's take a look real quick at how I would set it up. I would set it up as this line segment compared with this line segment. So 8 over 7.2. And set that equal to 6.4 over Y. So that's going to give me 8Y is equal to 7.2 times 6.4 is 46.08. Then I would divide both sides by 8, and I would get 5.76. And I guess if you wanted to round it off to keep your units consistent with everything else, that would round off to 5.8 yards.
Why don't we do significant figures on this?
That's really not what I'm interested in teaching.
So
I'll let your science teachers worry about singing, because in math we're dealing with theory and not application most of the time. So really significant figures only come when you start applying the math and you need a real world answer. I'm more concerned about, do you understand the procedure and can you give me an exact answer?
So would both answers be correct?
In this case, since all of the other units were rounded to one decimal place, I probably would not count off unless I told you I want two significant figures or give me an exact answer. All right. The last theorem we're going to learn in here for Unit 7 is the triangle angle bisector theorem. Basically what it says is if you have an angle bisector, so it's the angle bisector theorem, I'm looking for an angle bisector. If I've got an angle bisector, then it's going to split that triangle up proportionally. The side length of this with this part of this line is proportional to this side length with this line. So we have triangle ACB. CB got divided into two parts, CD and DB. So AC over CD, here's how I'm going to set it up. AC over CD would equal AB over BD. So this over this equals that over that. I just do the left side and the right side. So in setting this one up, first thing I'm noticing is that it's an angle bisector. So I'm going to do 10 over 12 equal 18 over x. You might not set it up exactly like that, but after you cross multiply, we should have the same thing. So you should have 10x is equal to 216, and then x is just equal to 21.6. Everybody okay with that? Okay. Go ahead and do this one real quick. Hopefully you set up the problem similar to what I'm doing. I'm going to do y over 9.6 is equal to 24 over 16. I'm pretty consistent. I always go boom, 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 boom. Key was that it was an angle bisector. So 9.6 times 24 is equal to 16y. 9.6 times 24 is going to equal 230.4. And then I'm going to divide both sides by 16. And I get 14.4. Everybody okay with that?
Yep.
Any questions? All right. That's pretty much it. There's your homework.